Okay, great. So go to the PowerPoint. Okay, so for our homework, we have to show and explain the process of this problem from chapter 5. So the problem is a series of 2-point crosses were carried out among 7 loci, A, B, C, D, E, F, and G, producing the following recombinant frequencies. Using these recombinant frequencies, map the 7 loci, show their linkage groups, the origin linkage group, and the distances between the loci of each group. Um, and so here are the loci, the recombination frequencies, and then we have 2 groups, 7 loci. Here are some basic concepts that you need to know in order to work out the problem. 50% recombination indicates that the genes assort independently. Less than 50% recombination indicates linkage. And then another thing to know is that in genetics, the coefficient of coincidence is a measure of interference. That's what we want to look out for because it might pop up in one of our problems. In the formation of chromosomal crossovers during meiosis. The coefficient of coincidence is typically calculated from recombination rates between 3 genes. So that kind of leads us into, because it already says 3 genes and we have 7. So I'll show you how we work that out with 7. So first, I will look and see what has 50%. Because if it has a 50% recombination frequency, it will not be in the same linkage group. So A and C will not be together. A and F will not be on the same linkage. A and G will not be in the same linkage. B and E will not be in the same linkage. B and F will not be in the same linkage. B and G will not be in the same linkage. So that leaves us with A and B, A and D, B and D. Now, we have B, and D. Starting with the most tightly linked genes is D and B. And so we look for other genes and find only A has less than a 50% recombinant with D and B. So one linkage group consists of D, B, and A. We know that gene B is between D and A because the distance of D to linkage D to A is 14. Let me make sure that's right. Yes, linkage of D to A is 14. So note that even though I wrote right here the distance D to B is actually D to A. And then I show you. D to A is 14. B to A is 10. B to D is 4. And I got that information from over here. 10, D to A is 14, B to D is 4. Luckily, these all add up. 4, B to A is 10, and then you add them up, D to A is 14. But it's not going to always add the 2, D to B and B to A, or whatever your letters will be. Sometimes they won't all add up to this overall number. And I can show you that for the next problem. So similarly, we find a second linkage group with E, C, and G. So C is going to be in the distance, and then the distance between E and G is 18. So it's a little bit different than the first linkage group. So right here we have E and C is A, C and G is 12, and then E to G is 18. And this is where we got that information from. C and E is 8, C and G is 12, E and G is 18. And we could cross out the rest because they had 50% recombination frequency or more. So it cannot be C or D, it couldn't be C and F, it couldn't be D and E, it couldn't be D and F, it could not be D and G, it could not be E and F, it could not be F and G. So that left us with E, G. But as you can see, 8 and 12 is 20, and what we actually got was 18. So that's where interference comes in. And remember that definition. So that's where interference comes into play, where we use the actual calculation of the distances, and that becomes 18. So that talks about 6 loci, but remember that we had 7, and so G is not linked to either of these groups, and it's on the third linkage itself. The reason being is because it had a 50% recombination frequency to all the other loci. So C and F were 50, D and F were 50, E and F were 50, F and G were 50, D, A, and F were 50. So if it was 50, that means it could not be in the same linkage group, and that resulted in F being by itself. So we want to make sure we answered all the questions, showing the linkage groups, loci in each linkage group, so DBA, ECG, and you go with the most tightly linked genes to the genes that go a little bit further out but still have a 50%, a less than 50% recombinant. And then the distances between the loci of each group. And then this is how we see the distance between the number B underneath. The total that we have will show on our little triangle. And that is how we do the mapping of the loci.